Okay, in this lesson we're doing complex fractions with rational expressions. So to start off, we're just going to look not at polynomials with variables, but just plain old fractions with numbers, okay? So when we see something like this, 1 divided by 2/3, this is what it really looks like. And we want to take that back half, flip it as reciprocal, and times it by 3/2, okay? So again, we're used to saying, all right, if we see that division sign, what do? We change to a multiplication sign, flip the fraction reciprocal, and then we simply say, okay, 3 divided by 2 is our final answer, okay? But I just want to notice the setup here of how we see it, because that's how we're going to see our problems, and really, that's why we flip the fraction. Okay, so to do this, we notice we have a addition problem in the denominator. So the first thing I want to do is add those together. So I want to get a common denominator. Here I need to add a 3. Here I need to add a 2. So I'll do it to the top and bottom. And we simply have 1 divided by, I'll just do it in different colors so we don't get confused by the fractions. And we have simply 5 divided by 6. So now we have 1 divided by a fraction. What do? You flip this portion, because it's in the denominator, and we're going to have a final answer of, let's say, 1 times 6/5, which is the same thing as this 6/5. Okay, so notice the process is you need to combine your fractions in the denominator, get a single fraction, and then you can do division. So what we're doing is really combining the addition and subtraction of polynomials with multiplication and division of polynomials. So let's say do the same thing here. We need to combine fractions. To get 4, you need to add a 2 to both the top and the bottom. So on the bottom here, we have simply 2 plus 1 is 3 divided by 4, and on the top, 2/3. So when I see this, what's really happening is I want to flip the fraction, so that's 2/3 times 4/3, okay? And notice here, what we have here is, the 2 3's on the bottom, the 4 and the 2 on the top, so we have simply 8/3, or 8/9, I'm sorry. Okay, because we multiply across here, okay? So notice the setup there. A lot of people get anxious here and say, oh, we have 3's on the top and the bottom. Can we cross those out like this? No, you can't do that, okay, because one's in the denominator and the other one's also in the denominator, because it's in the denominator here and down here, okay? So that's why you have to look for that flip. So I'm going to go ahead and undo that real quick so we don't get confused by that. And let's go back to full screen. Okay, so that's how we do with numbers. Now let's take a look at rational expressions with polynomials in them. Okay, so first I'm going to do is simplify the bottom. So what I have to do is first say, okay, what am I missing? Here I'm missing an x, and over here I'm missing an x plus 4. Okay, so I want to add that to the top and to the top here. So over here I'm going to simply have x plus 2x plus 8. All I did is distribute and combine the top. And on the bottom, we have x times x minus 4. I'm going to leave it as factors. Now on the top here, what I'm going to do, notice, is let's do one more step here. And I'm going to simplify the top. So this is really 3x plus 8. And this is going to be simply, I'll leave it as factored form, because I might cancel stuff in the end. So I want to leave it in factored form. I'll do this in red so we can see the difference here. And on the top here, we simply just bring it over 5 over x plus 4, and then 5 over x plus 4. Okay. So now that we have a fraction divided by fraction, I'm going to rewrite it as a multiplication problem. And notice I'm going to flip the bottom portion. So on top here, I'm going to put x times x plus 4. And on the bottom, I'll put the other half, 3x plus 8. Now, good. I'm going to put parentheses around all my factors so I can see what's what. Okay, and that's the key. Now it's a large multiplication problem. What am I really looking at? X plus 4 gets canceled out, and that's really it. So final answer is 5x divided by 3x plus 8. Okay, so that's what we're looking for. So again, combine fractions. Then once you have fraction divided fraction, then flip it with multiplication. All right, let's take a look here at another example. So notice here, this one again is just with the numbers. So what am I missing here? I'm missing a 2. So I need a common denominator. So what I'm going to have is simply 2x minus 7 divided by 10. On the top, notice I'm going to combine these fractions. I'm going to multiply both by 2. if x minus 2x is negative x divided by 6. Now that I have those, I'm going to go ahead and flip the fraction. So I'm going to start with negative x divided by 6. I'm going to go ahead and flip the bottom and show it as 10 divided by 2x minus 7. Again, I'm going to put everything in parentheses so I can see my factors. And once I do that, this is really understood to be one big fraction problem. And I'll look, okay, what can be reduced? You can take a 2 out of here and out of there. Final answer is simply going to be negative 5x divided by 3 times 2x minus 7. Again, you can leave this in factored form. Yeah, I'm fine. You know, some people are going to show it like this and go ahead and distribute that bottom. And I'm fine with either one, honestly. Okay. So I'll put a little note here, both okay, going that way. Okay. Just going to look ahead here. So notice in this one, notice we don't have fractions. So the first thing I want to do in this example is I want to make it, turn everything into a fraction, and then realize, okay, what can be combined here? So on the bottom here, I need to add an x, both top and bottom, so I have a common denominator of x, and now we have 2 plus 3x on the top. Look at the top here, I need the x here and here, so now I'm going to have 2 minus 4x on top and a common denominator of x on the bottom. Okay, now if I rewrite this, I'm going to take the top portion, show it as a fraction, and then I'm going to multiply by the back half. Okay, and again, I'm going to flip, so I'll put the x on top and 2 plus 3x on the bottom, and notice what happens here. Okay, here's a factor, 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 here and here. Okay, notice what I can do here. I'm going to see this. I'm going to rewrite that as a 2 out and do 1 minus 2x. Okay, so I'm going to look. Can I take a 2 out of anything? I can't, but I want to look for that to make sure I know what's what. Those cancel out, and what you're left with is 2 times 1 minus 2x divided by 2 plus 3x. And again, you can't cancel these 2's because the parentheses have to match, and that's what we have here. Okay, so I want to show that problem to show, you know, how do you change polynomials into fractions. Okay. What I want you to do is I want you to try this problem here. Again, you know, here are your factors. Again, to get you started there. So let's say if you try this one, okay? And we'll talk about this next in class.